Hello everyone. My name is Raymond Kim, and this is my presentation for chapter 2. So, I wanted to use this graph here as my example, and I think a couple things we should note in this graph is that this initial theta here is 60 degrees, and obviously it changes throughout the whole graph, and that this peak point here has this. You see this orange, that's the y velocity. It has a 0 here because obviously it's the peak, so it's not going any higher, and y has gone to 0. And also the x of velocity is constant throughout the whole motion. It's just some things to keep in mind while I could give this presentation. And so what I did to figure out all the velocities at every single point, I used this formula. The final velocity equals initial velocity plus negative 9.8 meters per second squared times 4 seconds. And so using this formula, I was able to get 39.2 meters per second for the initial y velocity. And I used 0 as the final velocity because, it just makes the calculation simpler. You just have to move this to this side because it's just 0. So you just add 9.8 times 4. And you get 39.2. And using 39.2, I divided that by sine 60 because the sine 60 is opposite over hypotenuse, so the opposite from the angle was the y initial y velocity, which is 39.2, and over the hypotenuse, which I don't know. So using 39.2 divided by sine 60, I got 45.26, which is the resulting vector. And with that, I was able to use that to multiply with cosine 60 because to find the x velocity. And I did that because cosine is adjacent over hypotenuse, and the adjacent is what we want to find for the x velocity. And so I basically just multiplied the hypotenuse to cosine 60 to get 22.63. And the x velocity was constant throughout the whole motion, so you only need to calculate that for that once, and you're at 22.63 for the x velocity. And so what I did to find all the y velocities is I just tampered with this formula over here. And so let's say, the initial point, I use this formula. And so if I wanted to go 1 point above to find the y velocity of that, I just switch this 4 to a 3. And I'll just do that I'll show you that right here. I just changed the 4 to a 3. And because 39.2 is just 9.8 times 4. And then, so to get the third point from the peak, just do 9.8 times 3, and you get 29.4. And I just basically did that. Go down times 2, then you get 19.6, and then times 1, you get 9.8. And then obviously at the top, you just do times 0 because that's the final point I was referring to in the formula. And then on the way down, what I did was I just did this. I just made the final point as 39.2. And then I started going down again. Here, because when you look at this graph over here, to here is 1, 2, 3, 4 seconds. So then for this point, or here 1, 2, 3, 4 seconds, and then from this point it's 1, 2, 3, and then 1, 2, and then 1, and then 0. And then on the way back down, in order to find that, since I know that the initial velocity here is 39.2, for this one it should be negative 39.2 because of the symmetry. So what I did was I made this the starting point and I made this the final point. And so 1, 2, 3, 4 seconds. I basically, made the final point, 39.2, and then made this as 4 in order to get, or sorry, 3, because it's 4 starting from the very peak point, but I'm starting from the point under that. So yeah, I do times 3. And yeah, 9.8 times 3, you add it here, you get, so 9.8 times 3, when you add it to this, it's this is 9.8 times 4, so you just get 9.8 but negative, because 9.8 times 3 is less than 9.8 times 4. And yeah, I just did what I did for the on the way up, just reversed on the way back down, and I just made this times 2 to get negative 19.6, because negative 9.8 times 2, you add that to negative 39.2, which is 9.8 times 4, so you just get 9.8 times 2, which is 19.6, negative 19.6. And you do the same, you do times 1, and then you add it to that, and you get negative 29.4, and then, yeah, when you're at the point right at the x-axis, it's times 0, because that's the point I was using, and times 0, you just get negative 39.2. And yeah, in order to find the final point, I actually just use this formula right here. Yeah, so basically I switched around, because for the previous ones I had the final velocity, but I wanted to find the initial velocity, and then you get the initial velocity. But for this one, I switched it around. I had the initial for this final point here I'm talking, because for this one I have the initial velocity, and I wanted to find the final velocity here. So what I did was, I don't know the final velocity, but I have the initial plus negative 9.8 meters squared times 1 second, because it's only one increment down, and that gives me the initial velocity of negative 49 meters per second. So yeah, I thought chapter 2 was pretty interesting, analyzing the falling objects, using gravity and using all these different kinematic equations and plugging in all the specific points that we need to in order to find the missing value that we want to. Yeah, I hope that was useful. Like Miss Jamali definitely said that wasn't a way that she had thought of before, and she thought it was really interesting. So looks like not many people might have thought of using or going the direction that I did, but I think it was really easy for me to just understand it, because, I mean, especially because she said that all the points were only 1 second in between. If they were all different times increments in between, it definitely would have been much harder. But yeah, thank you for listening.